Good afternoon, students. In the morning, we have seen the few numericals on solution of state equations, and the last topic in this chapter was the transfer function from the state model. Right, the state model will be given, and we have to obtain the transfer function. Few numericals we have solved in the morning, so we will continue with one or two numericals. Right? Okay, all these things we have studied in the morning. I will take up the numerical. Okay. Okay, fine. We were discussing this numerical in the morning, right? Okay, vector A, vector B, vector C is given. Vector D is not given means it is 0, right? It is not given. Find the transfer function of the given state model. Right, we know the transfer function equation C inverse B plus D. How to remember? I already told C inverse B plus D. This is matrix C, matrices B, matrices D, right? C, B, D. Okay, first we will obtain Si minus A whole inverse. So we know that the Si minus A whole inverse is given by adjoint of the matrix divided by the determinant, right? Okay, first we will obtain Si minus A. Already I told how to obtain Si minus A. So you will have to choose the identity matrix which should be same as the order of matrix A. Matrix A is 3 cross 3, so we will choose the identity matrix also 3 cross 3, right? The order is 3 cross 3. So multiply S, so this is Si minus A. So we got Si minus A. Is it fine? Okay, next we want to calculate Si minus A whole inverse. So first we want to calculate adjoint of this matrix and determinant. First we'll find out the determinant, then later on we'll go for adjoint, right? So first we'll find out the determinant. Okay, we'll go to the next slide. So determinant of Si minus A. Yes, we'll find out the determinant of this matrix Si minus A, right? So S into, you know this, right? Plus, minus, plus, right? These signs will be writing. Is it fine? Okay. S into, I'll start S into, I'll go to the next slide. S into, so S into S plus 3, S square plus 3S, S square plus 3S, then minus. So my plus into minus, right? Minus of minus, it will be plus 2 1 2, right? Plus 2, right? Minus into minus, it plus 2, right? So S into, so leave this column, leave this row. So S into S plus 3 minus of 2 into minus 1, right? That we have done. The next minus 1 into, so but right, minus of, see this is minus 1, so minus of this minus is there, minus of minus 1, let me make it plus, right? So be careful, this minus sign I have to take, but anyhow minus 1 is there, so minus into minus it will become plus. So leave this column, leave this row. 0 into S plus 3 is 0, so minus into minus it will be plus, so 1 into 1 is 1, so I am getting 1 here. Is it fine? Okay, somebody is trying to come to the class, let me admit them. Okay, I hope they had come into the class, I think. Okay, let it, I will continue. Okay, we were obtaining the determinant, right? So this is over. The next last 0 into anything will be 0, so it will be 0, so I will not, right? So what I will be getting, so multiply S cube plus, just multiply S with this 3S square plus 2S plus 1 into 1 is 1, right? So plus 1. So this is the determinant. Then next we will find out the adjoint of this matrix S minus A. Adjoint of the matrix Si minus A we want to find out. So in order to find out this, first we will find out the cofactor. Anyhow this, right? So Si minus A, this is 3 cross 3 matrix, right? So first we will find out the cofactor of this matrix, right? So cofactor, let me write cofactor of, so to find adjoint, cofactor of the matrix. So this is adjoint of means cofactor matrix transpose, right? So okay, let it, will cofactor of the matrix Si minus A. Right, you know how to find out the cofactor. So I will take care about the sign later, right? So sine rule is there. Anyhow, you know, if it is 3 cross 3 matrix, the sine rule, you know, plus, minus, plus, right? Minus, plus, minus, plus, minus, plus. This is the sine rule. I will take care of the sign later, right? Sine rule. So first I will find out the cofactor. Then I will take the transpose so that I will get adjoint, right? Okay, sine rule, we will keep it aside. So first we will find out the cofactor of S. Cofactor of S means leave this column, leave this row. S into S plus 3. Let me multiply here and write it. S into S plus 3 means S square plus 3S. So once again 2 into minus 1, minus of 2 into minus 1. So minus minus plus it is, right? 2 1 are 2. So this is the cofactor of this S, right? Let me write it. S square plus 3S plus 2. I hope it's correct. Let me check it once again. S into S square plus 3S, 2 1 are 2. So minus into minus it is plus. S square plus 3S plus 2. S square plus 3S plus 2. Okay, this is the cofactor of this S. Next, similarly, we will find out the cofactor of all the elements. Cofactor of this minus 1. Leave this column, leave this row. 0 into S plus 3, 0, right? Then next minus of. So minus into minus it will be plus, 1 into 1 is 1. So cofactor of minus 1 is 1. Then cofactor of 0. So leave this column, leave this row. 2 into 0 is 0, minus 1 into S. So minus S. So the cofactor of 0 is minus S. Similarly, the cofactor of 0. Leave this row, leave this column. Minus 1 into S plus 3 means minus S minus 3. Minus 1 we will multiply. We are finding cofactor of which? This element, right? So we will leave this row and we will leave this column. Minus 1, sorry, minus S minus 3. 1 minute, let me check it. Yes, so it's correct. If I am making mistakes, please correct me, right? So minus S. Next 2 into 0 is 0. So I am getting minus S minus 3. Minus of S plus 3 also I can write. So minus S minus 3. Let me write it. Minus S minus 3. Next cofactor of S I want, right? So leave this column, leave this row. S into S plus 3 means S square plus 3S. So leave this column, leave this row. S into S plus 3, S square plus 3S. Plus 1 into 0 is 0. So S square plus 3S I am getting. Please correct me. Don't wait till until the last moment I make mistake, right? Because finding cofactor should be correct. The next cofactor of this minus 1. So leave this row, leave this column. Leave this row and leave this column, right? This row we will leave, this column. 2S, right? 1 into 1, minus into minus, so plus 1, 2S plus 1. Next, we will find out the cofactor of this one. So leave this column and leave this row. Minus 1 into minus 1, it is 1. Next, sorry, this one we are finding out, right? So leave this column, leave this row. So 1, it is 0. So only 1. This is 1, right? Please go cross verify if it is okay. Next, cofactor of this element 2. So leave this column and leave this row. So S into minus 1. So it is minus S. So we are finding cofactor of this. Leave this column, leave this row. S into minus 1 is minus S. 0 into 0. So minus S I am getting. Next, cofactor of S plus 3. So leave this column, leave this row. S into S is S square. So the other is 0. So S square I am getting. So this is cofactor, right? But the sign should be taken care. It should be plus here. Yes, fine. Second element should be minus. So minus 1. So here it should be plus. Plus into minus, minus. Then minus. So minus. So it will multiply. So it will become plus, right? So this minus is there. Corresponding to this, it is plus. Then minus of. I am using the sign rule here. This is plus. Then minus into minus. This will be plus. Right? Then plus. This is correct. So this is cofactor of Si minus A. You have to take care of this sign rule, right? And accordingly we make the changes here, right? Okay, fine. This is cofactor of Si minus A. Then we have to take transpose so that I will get adjoint of S minus A, right? So adjoint of Si minus A is nothing but the transpose of cofactor matrix, right? So take the transpose of cofactor matrix. So cofactor of Si minus A. So its transpose I have to take, right? So already I have the cofactor of Si minus A, its transpose. So rows will be converted to columns. So let me make it here. So this row, first row, it will be converted to column. S square plus 3S plus 2, right? Then minus 1, then minus S. First row is over. Next, take the second column, S plus 3, s square plus 3s, or else I can take common s, right? If I take s common, s plus 3, is it fine? I have taken s common. The next uh, s plus 3, this is our minus of 2s plus 1. The next third column, third row, it will be converted to column 1 s s square. So this is the adjoint of the matrix Si minus A. Then we need Si minus A whole inverse, right? So Si minus A whole inverse. So it is 1 by the determinant of the matrix, right? What is the determinant of matrix Si minus A? Where is the determinant? We have found out. Yes, this is the determinant. S cube plus 3s square plus 2s plus 1. S cube plus 3s square, s cube plus 3s square plus 2s plus 1. Let me check it once again. S cube plus 3s square plus 2s plus 1. It is correct. Then into adjoint, right? So 1 by determinant we have taken. Then adjoint of this matrix. So let me write the adjoint of the matrix here. So s cube plus 3s plus 2. Sorry, s square plus 3s plus 2. S square plus 3s plus 2. Then s plus 3, 1. S plus 3, 1. Next, minus 1, minus s into s plus 3. Then s minus of 2s plus 1. The next s square. Right, this is Si minus a whole inverse. But what we want, Si minus a whole inverse, I can multiply with C. What is matrix C? This one is C. So I can multiply with matrix C or matrix B. First we will multiply with C into Si minus a whole inverse. We will take it. C matrix is 1 0 0. So C into Si minus a whole inverse. C into Si minus a whole inverse. Right? Okay, first we will do this. C into Si minus a whole inverse. Only this part. Later on we will multiply with B. Right? C into Si minus a whole inverse. So what is C matrix? 1 0 0. Is it fine? Then Si minus, let me verify C matrix. So 1 0 0, it is correct. Then this is Si minus a whole inverse. S cube plus 3s plus 2 s plus 3 into 1 minus 1 s into s plus 3 s minus s minus of 2s plus 1 into s square. Okay.
Sir, x square plus 3x plus 2.
Which one, madam? Which one? Can you tell me?
Sir, in first row.
S square. Yes, I have written s cube. No, I have written s cube. Okay, thank you, madam.
Yes,
It is s square. Okay, fine. Such mistakes I will be making. Please correct me, right? So s square plus 3s plus 2s. This one I have written cube. Okay, others are correct, I think, right? Okay. So this is the matrix of the order only one row and three columns, 1 cross 3. But this one is 3 rows, 3 columns, 3 cross 3. So finally I will be getting 1 cross 3. 1 row, 3 columns. So we will find out Si minus A. Sorry, here also I have written wrong. Inverse I should write like this. It is equal to, right, we will multiply, right? So what I should get? Only 1 row, 3 columns. 1 row and 3 columns I should get. So multiply first row with first column. So 1 into this and remaining 0 into minus 1, 0 into minus s. So they will vanish. So 1 into this means first element will be s square plus 3s plus 2. First element. Right, 0 into minus 1 will vanish, 0 into minus, this will vanish. Then first row, second column. So 1 into s plus 3. The other two elements will vanish. So s plus 3 I will get, this is the second element. Then third element, first row, third column. 1 into 1 is 1. Other two will vanish. Right? So matrix multiplication is over, right? So I am getting 1 cross 3. 1 row, 3 columns. Next, C into S, then I have to multiply with B. Right? So C into Si minus A whole inverse into B. C into Si minus A whole inverse is this, s square plus 3s plus 2, s square plus 3s plus 2 first element, s plus 3 second element, 1 is third element. So what is the vector B? Vector B is 0, 0, 1. Column matrix 0, 0, 1. 0, 0, 1. Okay. So this matrix is having only one row and three columns. This is having three rows and having only one column. Right. So I will be getting 1 cross 1. So one row, one column. Right. Only one element. So let me find out this. C into Si minus A whole inverse into B is equal to, right, first row first column, this will vanish, 0 into 0, s plus 3 into 0, this will also vanish, then 1 into 1, I am getting only 1. C into Si minus A inverse, I am getting only 1, right? This is 1 cross 1 matrix, right? Then next, plus D. What is D? It is 0. So transfer function is C into Si minus A whole inverse plus B plus D, right? Okay. 1 minute. I have made one mistake. Can you identify what is that mistake I have made? Can anybody identify that mistake?
Magnitudes.
Magnitudes, not magnitude. This one I have left, no. This one, Si minus A whole inverse. So C into Si minus A, only I have taken this. What about this? Right? I have to write this. So let me write it outside. I don't have space here. So please correct me. Don't wait till last. This I have left. So I will be multiplying here. S cube plus 3s square plus 2s plus 1. Okay, this I have multiplied. This is outside, so let me write it. This I will be carrying forward. So 1 by s cube. So don't leave this. It is outside, right? Don't leave this. S cube plus 3s square plus 2s plus 1. Okay, next CSI minus into B. CSI minus this is fine. Let me append here. 1 by s cube plus 3s square plus 2s plus 1. So it is 1 by s cube plus 3s square plus 2s plus 1. So this entire thing I have left now. So I have to carry forward, right? So transfer function is y of s divided by the input u of s, that is equal to, the formula is C inverse B. C inverse means Si minus A whole inverse. C inverse B plus D. C inverse B plus D. So what is D is 0. It is 0 matrix, right? So if I add 0, so leave it. So C Si minus A, right? So transfer function is, this is the thing, final one, right? So 1 divided by, the transfer function is 1 divided by s cube plus 3s square plus 2s plus 1. I hope you got it. So if I am making mistakes, please correct me immediately, or else everything will go wrong. So this is right, answer is right. This is the transfer function. 1 by s cube plus 3s square plus 2s plus 1. Okay, we will be solving one more numerical of the 3 cross 3 order, and we will wind up this chapter. This unit 5 is over. Only 1 hour portion is left out. So that I will be taking in the next week. Maybe Thursday, Friday I will not be taking, right? Okay. I will intimate one day before that 1 hour class when I will be taking. Maybe 1 or 1.5 hour, right? Okay, next. This is the last numerical. Obtain the transfer function of the system defined by the following state space equation. This is x dot vector is given, x dot equal to ax plus bu, right? So x dot equal to state equation, let me write it here, x dot equal to ax plus bu. This is the state equation, and output equation is y equal to cx plus du. You should be knowing it. So this is vector a, right, ax, and this is vector b, right, this is vector b, and this is u, right? Then this is vector c, and d vector, it is 0, so d vector is 0, right? Okay, fine. So we know vector a, vector b, vector c, vector d, everything we know. So if I know vector a, b, c, d, vector a, vector b, we have obtained the transfer function. In the same way we have to do, right? We will continue. So let me write, transfer function is equal to, we know the formula. Actually I thought of giving homework, but let me do it, no problem. Transfer function is equal to C inverse Si minus A whole inverse, C inverse B plus D. So D is 0. So the transfer function will be, since D is 0, right? So but D is 0. So the transfer function will be C Si minus A whole inverse B. That's all, because D is 0. So call this as equation 1. So first we will find out Si minus A whole inverse. So before that we will find out Si minus A. Si minus A. So what is the order of the matrix A? So matrix A is 3 cross 3. So I should be also 3 cross 3. So identity matrix I should be also 3 cross 3. 1 0 0 0 1 0 0 0 1. So this is the identity matrix of order 3 cross 3, and I have to multiply S for it. So I'll multiply S and write it S 0 0 0 S 0 0 0 S. I am multiplying S for the identity matrix minus the vector A. Vector A is this, write it, minus 1 plus 1 0. Minus 1 plus 1 0 0 minus 1 plus 1 0 0 2. Right, minus 1 1 0 0 minus 1 1 0 is correct. Okay, we'll subtract it. So S minus of minus S plus 1 is the first element. The next 0 minus 1 means minus 1, 0 minus 0 0, third element. Then 0 minus 0 0, S minus of minus 1, S plus 1. Then 0 minus 1 minus 1, 0 minus 0 0, 0 minus 0 0, then S minus 2. So this is Si minus A. But what we want? Si minus a whole inverse. Si minus a whole inverse we want. So it is equal to the adjoint of the matrix Si minus a divided by the determinant of the matrix Si minus a. Si minus a. So first we will find out the determinant of the matrix Si minus a. Determinant of the matrix Si minus a. So already I have the matrix. 1 minute. Okay. Already I have the matrix Si minus A. We will try to obtain the determinant of this matrix Si minus A. So let me take the sign plus minus plus, because I want to determine the determinant of this matrix. So S plus 1 into S plus 1 into, so leave this column, leave this row. S plus 1 into S minus 2. S plus 1 into S minus 2. So 0 into minus 1 is 0. So this is over. Next, minus, this minus is there, and this minus. So minus into minus plus 1 into, so leave this column, leave this column, leave this row. 0 into S minus 2 is 0. 0 into minus 1 is 0. So it is 0. Then next last column is 0, because plus 0, everything, right? It is 0. Anything multiplied by 0 is 0. So determinant is, just we will multiply and write it. So S plus 1, you will multiply this S square, S square, S into S is S square, S into minus 2, minus 2S. So 1 into S is S. So 1 into minus 2 is minus 2. So S plus 1 into S square minus 2S plus 1. So minus 2 plus 1. So minus S minus 2. I hope it is correct. I have not made any mistake, right? So let me multiply S into S, S cube, plus, sorry, not plus, plus into minus, minus S square minus 2S. Next, plus 1, multiply this, S square minus S minus 2. So S cube minus S square plus S square, they will get cancelled. So minus 2S minus S minus 3S minus 2. So this is determinant of the matrix Si minus A. So this is the determinant. Then next we will find out the adjoint of the matrix Si minus A. Next, find adjoint of matrix Si minus A. So in order to find out adjoint of Si minus A, first we have to find out cofactor. Cofactor of matrix Si minus A. Okay, and sine rule, let me write it here. Anyhow, matrix Si minus A is 3 cross 3. So sine rule, I will be writing by side. Sine rule. So plus, minus, plus. So minus, plus, minus. Right, this is the sine rule. Alternative sign you have to take. Right, plus, minus, plus. Right. So I have taken correct. Right, fine. Then I will apply this sign. First we'll find out the cofactor, then we'll take the transpose, right? First cofactor of Si minus A. So it's also 3 cross 3 I should get. This is Si minus A. Cofactor of S plus 1 I want. So leave this column, leave this row. So let me change the ink color. Let me change the ink color so that I will not go wrong. So I am finding the cofactor of this S plus 1, right? So leave this column, leave this row. S plus 1 into S minus 2, right? So S plus 1 into S minus 2 and 0 minus, okay, S plus 1 into S minus 2. Let me write it here. S plus 1 into S minus 2. Okay, cofactor is over. Next, cofactor of this minus 1 I want to find out. Cofactor of this minus 1 I want. Cofactor of this minus 1. Leave this column and leave this row. Right, 0 into S minus 2 is 0, 0. So I am getting 0. Cofactor is 0. Right? Next, cofactor of this 0. Cofactor of this element 0. So leave this column, leave this row. Leave this column, leave this row. 0 into this, 0 into. Once again I am getting 0. Right? Whatever we are getting, right, write it. Next, cofactor, once again I will change the color. Cofactor of this element 0. So leave this column and leave this row. So minus 1 into S minus 2. So minus of S minus 2, because minus 1 I am multiplying. Because I am finding out this, leave this row, leave this column. So minus 1 into S minus 2, fine. 0 into 0 is 0. So I am getting minus of S minus 2. Minus of S minus 2. Next, cofactor of this element, let me change the color so that I will not go wrong. Cofactor of this element, S plus 1. So leave this column and leave this row. S plus 1 into S minus 2, same as this. I am getting S plus 1 into S here. Leave this column, leave this row. S plus 1 into S minus 2, it is here. S plus 1 into S minus 2, 0 into 0. Right? So S plus 1 into S minus 2 I will get. S plus 1 into, sorry, I should write here. S plus 1 into S minus 2. So not this one, right? Okay, next, last one. This cofactor of this minus 1. So leave this column, leave this row. Leave this column, leave this row, right? So S plus 1 into 0 is 0, 0 into minus, so I am getting 0 cofactor, right? Next, let me change the color. So cofactor of this 0, right, this element. So leave this column, leave this row. So minus 1 into minus 1, so it is plus 1, right? Then minus of 0, and so minus 0. So I am getting 1. I hope you are getting. So the cofactor of this means leave this column, row, and leave this column. Minus 1 into minus 1, it is plus 1, right? So minus plus 1, and this is 0. 1 minus 0 is 1. I am getting 1, this one. Next, cofactor of this element 0, right, this one. So leave this column, right, and leave this row. So S plus 1 into minus 1, so minus of S plus 1, minus 1 into S plus 1, because I am finding out this, leave this column, leave this row. S 0 into 0, so minus of S plus 1, so minus of S plus 1 over. Then last column, last element, the cofactor of this S minus 2 I want to find out. So leave this column and leave this row. S plus 1 whole square, 0 into this, so S plus 1 whole square I am getting. So S plus 1 whole square. I hope it's correct. Then I have to take care of sine rule. I have to use the sine rule. The elements of cofactors I have found out, sine rule plus First is plus, second element is minus, second element is plus. So it will not affect the anyhow, it is 0. So it is plus. Come to this, it is minus. Minus into minus, this will become plus. This, right? This will become plus. Because this one is minus, right? Minus into minus, this will become plus. Anyhow, this is plus, this is minus 0 means minus 1 and the same. This is plus 1, fine. This one, minus into minus, this will become plus once again. Here it is minus, right? So minus into minus, this will be plus. So now it is correct. Then we will take the transpose, adjoint of the matrix Si minus A. So adjoint of the matrix Si minus A is equal to the cofactor transpose. Cofactor of that matrix, cofactor of the matrix Si minus A, its transpose, right? We'll take the transpose and we'll write the adjoint here. Okay, sorry. It is 3 cross 3. So this S plus 1, S minus 2, 0, 0, right? So this row will become column there. S plus 1, S minus 2. 0, 0. S plus 1, S minus 2, 0, 0. Next, S minus 2. Next, S plus 1, S minus 2. Next, 0. Next, third row, 1, S plus 1, 1, S plus 1. Next, S plus 1 whole square. I hope it is correct. I have not made any mistake, right? Okay, S plus 1 whole square. Whole square. Right? Okay, fine. 1 S plus 1 S plus 1, right, fine. This is the adjoint. Next, what we want? Si minus A whole inverse, right? So, Si minus A whole inverse. So, 1 by the determinant. What is determinant we got? This is 1 by this determinant. S cube minus 3S. S cube minus 3S minus 2 into the adjoint of the matrix. Adjoint is this one here, right? Let me simplify and write it, or directly, okay, let me multiply and write it. So let me multiply here S plus 1 into S minus 2. So what I will be getting? S square minus 2S, then S minus 2 plus S minus 2. So what I will be getting? S square minus 2S plus 1 means minus S minus 2. This element I will multiply. Next, S minus 2 as it is, and put in brackets, then 1. Next, 0. Then we will multiply S plus 1 into S minus 2. Already we have the same element. So S square minus S minus 2. Next, S plus 1. Then 0, 0. A plus B whole square I can apply if I want, right? A square plus B square plus 2AB. A square plus B square plus A square plus B square plus 2AB, right? 2S. Okay, this is Si minus A whole inverse. But what is the transfer function? C into, transfer function is C into Si minus A whole inverse into B. First we will multiply, let me take C or B. I can multiply C into this, or B, Si minus A inverse into B, whichever is possible, right? So this is matrix B. And C, where is matrix C? This is matrix C. Let me multiply C into Si minus A whole inverse. C into Si minus A whole inverse. What is C? What is C? C is 1, 0, 0. This is C, right? C is 1, 0, 0. 1, 0, 0. So what is the order of the matrix? Only 1 row, 3 columns. Then what is Si minus A whole inverse? I have this. Let me write it outside, right? So first I will write this. I will take this to the right side, right? So S square. Please, if I miss it, please remind me. S square minus S minus 2. S minus 2, 1, 0, S square minus S minus 2, S plus 1, 0, 0, S square plus 2S plus 1, S square plus 2S plus 1. I should not leave this one I have to take 1 divided by S cube minus 3S minus 2. Next, so this is matrix 3 cross 3. So finally I will be getting 1 cross 3, right? So C into Si minus a whole inverse. So what is the matrix size I am getting? Only 1 row 3 columns, right? 3 elements I will be getting. 1 row 3 columns. So multiply this. So first row first column 1 into s square minus, so 0 0, others are 0. So I am getting first element as s square minus s minus 2. This is the first element, right? Then multiply this first column with first row with second column. So 1 into s minus 2, others are 0. So I am getting second element as s minus 2. Then third element, multiply this first row with third column. So only 1 into 1 is 1. So other 2 it will be 0. I hope you are getting. So the matrix of the order, but we should not leave this. So 1 by s cube minus 3s minus 2. So what is the order here? 1 cross 3 I am getting. 1 row 3 columns. Is it fine? Next, c into si minus, this is over. I have to multiply with b, right? Then I will get the transfer function. So transfer function, finally we will take the transfer function is equal to c inverse, that is si minus a whole inverse, into b, right? C inverse b. D is 0, so plus 0 I will not write. So c into si minus a whole inverse is this, right? So let me write this first. 1 by s cube minus 3s minus 2. I am writing this first. Then I will write this s square minus minus 2 s minus 2. Let me put it in brackets 1. So this is c si minus. What is b? Vector b. Vector b is 0 0 1. This is vector du, right? Du. So 0 0 1. 0 0 1, right? 0 0 1. Yes, fine. So 0 0 1. It is column vector 0 0 1. Okay. So this is 1 row 3 columns, and this is 3 rows only 1 column. So I will be getting 1 cross 1 matrix, right? So the transfer function is, so this 1 by, as it is, 1 by s cube minus 3s minus 2. So I am getting only one row and one column, right? Means only one element. 1 row and 1 column means only one element I will be getting. So multiply with this. First 0, this will vanish. So I am getting only 1. This much, right? Yes, check it. First row, first column, right? 0 into 0, right? This 0 into this, 1 into 1. So the transfer function is 1 divided by s cube minus 3s minus 2. This is the transfer function. Let me verify with the answer. I hope they have written in factor form, I think. Yes, s plus 1 whole square into s minus 2 they have written. Whether I will get s plus 1, same thing, s plus 1 whole square into s minus 2, s plus 1 whole square, s plus 1 whole square into s minus 2. Whether I will get the same thing, s cube minus 3s minus 2, let me check it. A plus b whole square, a square plus b square plus 2ab, 2s into s minus 2. So let me multiply with s cube. So s, okay, no problem. S cube plus s into 1 is s plus 2s square. Then next minus 2s square minus 2 minus 2 to the 4s. So s cube is fine. So 2s square, 2s square, it will get cancelled, right? Then minus 4s plus s. So it is minus 3s, right? Then minus 2. It is correct, I think. S cube minus 3s minus 2. S cube minus 3s minus 2. Yes, it's correct. So the transfer function is 1 by s cube minus 3s minus 2. So this completes this chapter, state variable analysis, right? So I'll stop recording.